Alright, you knew it was coming. We were going to have to do it. Now we're going to do it. Inverse norm. Alright, so let's look at this problem here. It's the GRE score problem that we just were working on. Alright, now it says suppose Columbia wants to only accept the top 10%. Alright, top. So this is going to be the top half. What should their cutoff score be for acceptance? Alright, if remember the normal curve, right? Just kind of keep it in your mind. The top tail would be 10%. What's got to be everybody else? 90%, right? Because the whole curve makes 100%, 1. Now why is that important? Well, oopsie, come back. The inverse norm only uses the left tail, but the top would be the right tail, okay? So you're not going to put 10% in your calculator, you're going to put 90% in your calculator. So let's do it. Second distribution, number 3 inverse norm. Then you're going to tell it 0.90, got to put it in as a decimal, comma. Now, you wouldn't do a comma if you were doing a z-score, right? You just stop it right there and close the parentheses. But since we're not doing a z-score, we're going to type in the mean and the standard deviation. 1066, comma 191, close parentheses, enter. There you go. Their cutoff score would be 1310.776, so in other words 13.11. Excuse me, 1311. Right, unless you scored 1311, they wouldn't even touch you. Cool. Oops, sorry about that. I had to pause. You don't know the difference, but I had to walk away for a minute, but I'm back. Okay, so for this problem we're trying to find the 25th percentile. Remember the percentile. This is not the percentile rank, by the way. Percentile rank, it uses normal CDF. We did one of those in the last tutorial. Percentile is the percentage that's below you, right? So I'm telling you, look, this is the 25th percentile, so I know 25% is less than. Okay, I'm already giving you then the left tail probability. So it's inverse norm, so second distribution, number 3, inverse norm. I know what the percentage is, it's 0.25. Okay. If it was the 75th percentile, it would be 0.75, right? Comma 1066, comma 191, close parentheses, enter. There you go. The 25th percentile would be a score of 937. Right, rounding. All right, awesome. Now, what about the middle 95%? Right, if the middle is 95%, it's symmetric, right? That means that 5% is left over for the two tails. So that means 2.5%, which is half of 5%. Here, let me show you. Right, 5 divided by 2, enter. It's 2.5%. Okay, so what we're going to do is we're going to do second distribution, inverse norm, 0.025. You're making it a decimal, comma, 1066, comma 191, close parentheses, enter. Alright, there's the low score, right? So the low score, right, equals 691.6. Okay, what's the high score? The high score would be on the right hand side, right? Okay, so keep in mind what the curve looks like. Just kind of imagine a picture for yourself. You got 2.5% on the left tail, you got the middle making up 95%, and then you got 2.5% on the right tail. Okay, so think about the right hand cutoff score. It's got to be that there's 1 minus 2.5% over on that side. So let me show it to you. Second distribution, inverse norm. Now you can do this one of two ways. You can do 1 minus 0.025, comma 1066, comma 191, close parentheses, enter. Or, let me do it again, second, enter. Instead of doing that 1 minus business in the beginning, I could have just done 0.975, right? Because that is how much is to the left of the right-hand score. Right? The right tail is 2.5%, so to the left of that is 97.5%. They got to make 1, right? Look at this way, 0.025, 0.975. They got to make 1. Press enter. There you go. Why do they have to make 1? Because it's a curve, a probability curve, so they've got to add up to 1. So the high score would be, oopsie, 0.4. All right, done with that chapter. Oops, not done yet. I'll see you in 7-4.